innovations. So the first one is the anti-segment photography with intraocular lens and related anti-segment imaging devices. So as we know, the slit lamp cameras are very expensive nowadays, and it's not a cup of tea for everybody, especially the postgraduates and fellows. So we've come with a very simple way of doing this. That is taking the image using the smartphone by just keeping your hand on the slit lamp, keeping a 1 finger distance gap, and then taking the image. The basic thing is it should be clear. The round edges that we see here, it should be clear. So that is your endpoint to take the image. So if you can do this in your free hand, it is the most easiest way to take the image, and it will give you a really good quality image. And the second method is to use an adapter. So this adapter can be bought from Amazon. It just costs around 500 rupees, and once you know how to fit the smartphone onto the adapter, it becomes very easy. So once you clip it and put it on the eyepiece, again we have to keep that 1 finger distance between the phone and the slit lamp. So once you do that, it becomes very easy to take images. You don't have to you don't have to stabilize with a free hand because it is already fixed to the slit lamp, and it becomes very easy for you to take images. So this is how we do it. So you just need to adjust the camera in alignment with the eyepiece of the slit lamp. So once you do that, you again see there was a proper circular edge that you get. That is the endpoint, and you can even take fundus images using this. So what if you don't have a slit lamp and you need to take image? So this is a very do-it-yourself technique where you can take a chart paper, and cut it into 10 centimeter to 1.5 centimeter. So once you've done that, you can fold it on each other, and in between you can mark these areas, that is for making a hole to keep the intraocular lens. So once you do this, you attach a double-sided tape into it, and then take a paper puncher and punch out a small 6 millimeter hole onto the chart paper. So once that is done, you can just remove the double-sided tape and stick a intraocular lens. So I would suggest something around 15 to 20 diopters would do the trick. So once you've done that, you just have to place this arrangement on the smartphone, and that will change your smartphone into a macro photography device, and you'll be able to take images without a slit lamp as good as a slit lamp. So this is how it is, and you can use it on all your phones. So you just need to on the camera, take the video mode on the flashlight. It should be continuously on, and then start recording by taking it near to the patient's eye. So it is that simple, and you don't really require a slit lamp to actually take that good quality images. So these are all images which we have taken from the IOL ASPE. And for those who don't want to do it, they can also get this. This is a 3D printed ASPE, which can be attached. It's just like a clip, and it can be attached to the smartphone, and you'll be able to take images very easily. Just clip it on and then take images. That's so easy. So next one is the ASPE gonio. Basically, this is also using ASPE, but then the lens that we are using here is a 10 diopter lens. So you can use a 8 diopter, 9 or 10 diopter lens, and keep it on the gonio, and you can take images of the angles also. Then we come to Scooby-Doo, smartphone co-edit cobalt blue photography, do it yourself. So this is also a modification of the ASPE where we have added a blue filter, cobalt blue filter. So now because that is done, it is very easy to take blue photography also. So this is a video taken of Seedles positive without a slit lamp, just with the smartphone and the Scooby-Doo. Next I will go speak about IOL scope. So IOL scope is also a modification of the ASP device where we have used 30 diopter lens, four 30 diopter lens, kept one upon each other. So it was stuck using the Fevicol adhesive liquid, and as you can see, the first lens was stuck, and then once it gets dried up, the second one. So the similar way we add 30 diopter lens one on other, four of them. So the collective will be around 120 diopters. So that will increase your magnification of the smartphone. Once that is done, you can just fit it onto your smartphone, and when you put a slide against the illumination like a torchlight over here, you can just start so over here you can see the slide is put against the illumination like a torchlight, and then take the image this way. So you'll be able to take images of microorganisms and cells, etc. So these are the results. So this is a fungal rhizopus video. This is a KOH mount, the same fungal hyphae, and then even parasites can be taken very easily. The sheep botfly, which was removed from the conjunctiva, and this is caterpillar hair. So these images can be taken very easily with the smartphone itself. The next one was what if. So this is another study that we undertook in the OT. So there was a mucormycosis epidemic, and we took these samples at the OT itself, live demonstration of fungal hyphae during the OT itself, and over here you can see the hyphae over here. So this was another study that we took up. A similar way, we thought, what if we wanted to do this in the OPD setup? So we thought, let's attach this setup to the slit lamp. So remove the slit lamp, the pivot joint of the slit lamp, and then attach this smartphone adapter that I've already talked about. Around 500 rupees you'll get it in Amazon. So once you fit it to and attach the IOL scope, so then you will be ready to take images of KOH mount and etc. in your OPD itself. You just need to keep the smartphone there with the IOL scope attached, keep an illumination source down, and then you can take images of the fungal hyphae at the OPD itself. This is a small video showing the same. You can see how corneal scraping is done, and the IOL scope is already attached. Just put it on the slide, and then you keep it, and you are able to take images, and you can even identify fungal hyphae from this. So these are all other studies that we have done. We can be used for demo decks also. Then we have the slit scope. So basically we thought if we can take images of without a slit lamp with the smartphone ASP itself, but that is basically it's a diffuse light. So why not we make something with which we can get even the slit light. So we thought this was a problem statement, and that's why we opened up the slit lamp and saw what are the configuration of the slit lamp, and we tried to replicate that. So again we converted a torch by adding a slit onto the torch and adding a intraocular lens which would actually give us the slit. So this was the first video which was taken with my own eyes. So this was the slit that we have made. It looks a little thicker. So this was the first time we did it, and we got what we wanted. So then we thought, why not 3D print it? So we started 3D printing the actual size of whatever we wanted, and we were able to come up with a 3D printed torch adapter just for 350 rupees. And once we use that along with the ASP, you can see these are all the images that we were able to take with the smartphone ASP and the slit scope, and it was actually comparable to those with the slit lamp. And these are the different cataract grading we could take, and you can see how clearly the slit was working well for us. The second, the next, last one is the gimbal scope. So basically, we know that retinoscopy is very difficult to be done and to learn in the initial stages. So we thought there is a problem where the mentor is telling us how to see the reflex, and we cannot actually see the live demo. So we thought, why not make something, get a solution for this. So again, the mobile adapter, we fixed the smartphone, and now we can actually take images through the retinoscopy hole. So you can see the with moment reflex, you can see the against moment reflex. So this actually helps us to explain like live demonstration of retinoscopy, which helps the mentor make the student understand how and what he's actually trying to see and convey. And then finally the trash to treasure red cam. So basically this is a do it yourself method by which you can take a hand sanitizer bottle and cut it in this particular shape and insert a 20D lens. So once that is done, if you have a smartphone with the flashlight and camera within 1 centimeter, you can just attach it to this and you can start taking images. And these are all the images that we have taken without a fundus camera, just with the smartphone red cam. Another commercially available is John Deere Funduscope that he will talk about while telling about the 3D printing. Thank you. I would like to invite Dr. John sir for his